Welcome to the DIY Honda Garage channel. The DTC P0102 code signifies a malfunction related to the mass airflow MAF sensor circuit, specifically indicating low voltage. The MAF sensor plays a critical role in measuring the intake air that enters the engine, which is vital for proper fuel-air mixture calculations. This component is located directly on the intake air passage, making it a part of the vehicle's overall air intake system. For Honda Accord models from 2012 to 2017, the MAF sensor is a type of hot wire airflow meter that relies on an electrically heated wire. The engine's powertrain control module, PCM, which is an essential component for overall vehicle performance, measures the current required to maintain the temperature of this wire. If this current drops below a defined threshold, which is specified by the manufacturer, the PCM interprets this condition as a malfunction, thus triggering the DTC for further diagnosis. Understanding this fault code can help in quickly identifying issues that could affect engine performance, efficiency, and emissions control. To prevent the recurrence of issues associated with the DTC P0102, regular maintenance of the MAF sensor and its related components is crucial. Schedule periodic inspections to ensure that the MAF sensor and its wiring are intact, as physical wear can lead to electrical issues. It's also a good practice to clean the air intake system and the sensor itself, which helps maintain accurate airflow measurements. Ensuring that air filters are clean and replaced as necessary can prevent contaminants from affecting the sensor's operation. Additionally, regularly inspecting the sensor connectors will help catch any corrosion or looseness before they lead to future electrical issues. Following these preventive maintenance steps can help enhance overall engine efficiency and longevity. In summary, understanding DTC P0102 is critical for maintaining the performance of Honda Accord models from 2012 to 2017. The MAF sensor serves an essential role by accurately measuring the intake air needed for optimal fuel efficiency and engine performance. When faults occur, timely troubleshooting can mitigate further complications, ensuring the vehicle runs efficiently. The potential causes listed, coupled with a systematized approach to diagnosing these issues, provide a framework for effective repairs. Regular maintenance and checks can not only help avoid similar problems, but also ensure that the vehicle continues to perform at its best, contributing to a better driving experience. Keeping these key points in mind will assist in preventing future vehicle malfunctions. The mass airflow MAF sensor is designed to measure the volume of air entering the engine's intake. It operates as a hot wire airflow meter. This means it uses a wire that is kept heated, and as outside air flows over it, the wire cools. The signal sent to the powertrain control module, PCM, is based on how much current is required to keep the wire at a set temperature. This current reflects the rate of airflow. The MAF sensor is typically found in the intake air passage just before the throttle body. Its location is strategic. Being positioned in the direct airflow path allows accurate measurements that can significantly influence engine performance. If the voltage output from the sensor drops below 0.10 volts for more than 2 seconds, a fault code P0102 is triggered, indicating a potential issue with the sensor circuit. When diagnosing the DTC P0102, several potential causes must be assessed. The first possibility is a short to ground in the MAF sensor signal line, which could disrupt the voltage signal sent to the PCM. A disconnected or open MAF sensor line can also lead to no voltage being registered, resulting in inaccurate airflow readings. Another potential issue could be an open circuit in the MAF sensor's power supply line, meaning that the sensor simply is not receiving necessary voltage to operate correctly. Additionally, A failure of the MAF sensor itself cannot be ruled out, as internal faults can also generate the low voltage condition. Lastly, it is important to consider a potential failure of internal circuits in the PCM, as it processes and monitors signals from various sensors, including the MAF sensor. Drivers may notice several symptoms when the DTC P0102 is triggered. The most immediate sign is typically the illumination of the check engine light, CEL, on the dashboard. This alert indicates that the vehicle's onboard diagnostic system has detected a fault. Additionally, the vehicle may exhibit poor engine performance, characterized by a noticeable lack of power during acceleration or a rough idle when the engine is at rest. Increased fuel consumption could also be a side effect due to an incorrect air-fuel mixture caused by erroneous data from the MAF sensor. In some instances, you may even observe irregular operation during vehicle startup, further evidencing that the air supply is not being monitored correctly. Recognizing these symptoms early can help avoid more serious engine performance issues down the line. For the first step in troubleshooting DTC P0102, it is crucial to inspect the wiring and connectors associated with the MAF sensor thoroughly. Begin by examining the wires for any visible signs of wear, fraying, or damage that could potentially cause a short or open circuit. Pay especially close attention to the connectors. A corroded or loose connector can lead to inadequate electrical performance. Disconnect the sensor and conduct an inspection to ensure all terminals are securely seated. If any terminals appear to be damaged, they may need to be cleaned or replaced. A detailed visual inspection can often reveal issues that may not be immediately apparent and forms the foundation for further diagnostic steps. In the second troubleshooting step for the P0102 code, testing the MAF sensor's voltage output becomes imperative. Use a digital multimeter to measure the voltage at the MAF sensor's connector while the engine is running. A healthy MAF sensor should provide a voltage reading above the lower limit of 0.10 volts. If it's below this threshold, the sensor is likely faulty. Ensure that the engine is at normal operating temperature for accurate results during the test. Carefully follow the wiring harness to confirm that each connection is stable, as dips or fluctuations in the voltage reading could indicate other underlying problems. Document your findings for future reference, especially if further diagnostics are required. The third troubleshooting step involves checking the power supply line to the MAF sensor. This is crucial as the sensor needs a stable power source to function appropriately. Using the multimeter, measure the voltage at the power supply terminal of the MAF sensor. Ideally, you should observe a consistent voltage that aligns with the specifications outlined in the service manual. If the voltage is absent or unstable, this indicates an open circuit issue, which could be due to damaged wires or internal failures within the PCM. Follow the power supply path back to the battery and check for any connections that may be loose or corroded. Having an uninterrupted power supply is essential for the proper operation of the MAF sensor. In the fourth troubleshooting step, if the MAF sensor is determined to be faulty, it must be replaced. A new MAF sensor should be compatible with the specific vehicle model, Honda Accord from 2012 to 2017, to ensure optimal performance. After installation, it is essential to use a diagnostic scan tool to reset the diagnostic trouble codes stored in the PCM. Once the codes are cleared, observe the system's operation for any returning symptoms of DTC P0102 or related trouble codes. It's critical to ensure the engine runs smoothly, with no check engine light illuminated. Performing a final check will confirm that the repair was effective and that the MAF sensor is functioning as intended. Proper documentation of these procedures should also be maintained for future reference. After completing the repairs related to DTC P0102, it's essential to verify that all issues have been resolved. This involves making sure the DTC is cleared from the PCM using a scan tool. Conduct a test drive under various driving conditions to evaluate the performance of the vehicle. During the drive, observe if the check engine light remains off and if the engine operates smoothly without hesitation or rough idling. It is beneficial to monitor any standard parameters of the MAF sensor to ensure consistent readings during different vehicle conditions. Finally, make sure to double-check for any recurring issues that could indicate underlying problems. This thorough verification step plays an important role in solidifying repair effectiveness. Please like and subscribe to the channel. See you next time!